Hooke's law. Hooke's law, or the law of elasticity, is an empirical law deduced by English physicist Robert Hooke in 1660, which states that the deforming force is directly proportional to the change in the length of the body. Before I explain the Hooke's law, first let us grasp concepts of deforming force, restoring force, elasticity, and plasticity. Deformation means change in length, shape, or volume of any body, and the force that causes deformation is called deforming force. For example, when you stretch any spring, you apply force on the spring called the deforming force, and the spring undergoes deformation. While the spring is deformed, a force opposite to deforming force acts on the body to restore it to its original length. This force is called the restoring force. We observe that the spring restores its equilibrium or original position when the deforming force is lifted. The spring exhibits elasticity, or ability of a body to return to its original position when the deforming force is removed. But wait, are springs able to exhibit elasticity for any amount of force? The answer is no, not really. They only exhibit elasticity within the elastic limit, where the elastic limit is the maximum force per unit area that any object endures before any permanent deformation or plastic deformation. Plasticity, on the other hand, is the ability of the body to exhibit permanent deformation before it breaks. For example, we can say that when too much force is applied on the spring, it undergoes plastic deformation, which means that it will not return to its original position and it will be permanently deformed. Now, as we have learned what a deforming force, restoring force, elasticity, and plasticity are, we can better understand the Hooke's law. As we have stated earlier, Hooke's law states that the deforming force is directly proportional to the change in the length of the body. The deforming force may be applied to stretching, squeezing, bending, twisting, or compressing. Mathematically, Hooke's law can be represented by the expression where the deforming force is directly proportional to the change in the length of the body. As we know that in physics, whenever any quantity is proportional to the other quantity, it means that the first quantity equals to the product of the proportionality constant and that independent variable. In this case, Hooke's law can be represented by F is equal to Kx, where K is the proportionality constant and whose unit depends on the kind of elastic material, dimensions, and the shape of the elastic material. Now wait, isn't it confusing? Somewhere we see that force or deforming force is equal to Kx. In some books, it is written F is equal to minus Kx. That is because Hooke's law can be represented in terms of restoring force as well. As deforming force is applied on a body, the object deforms while at the same time restoring force acts on a body opposite to the direction of the deforming force. As in this case, the restoring force is directly proportional to the change in the length, in this case x, and the minus sign represents that this restoring force is opposite to the direction of the deforming force. And as force is a vector quantity, the negative sign only represents that it's in the opposite direction or opposite to the deforming force. Before winding up, let me answer one last question. Does Hooke's law apply to all materials? Yes, Hooke's law applies to all materials as long as the deforming force and the change in the length are proportional to each other. That is, these two quantities are within the elastic limit of the body. In short, all materials obey Hooke's law within the elastic limit of the body. Recapping. Hooke's law is the law of elasticity in which deforming force or the restoring force is directly proportional to the change in the length of the body within the elastic limit of the body, where elastic limit is the maximum force per unit area that any object can endure before it undergoes permanent deformation or plastic deformation and it does not restore to its original position. Hooke's law can also be explained in terms of stress and strain, which provides basis for Young's modulus. More about them in the next video. Smart end. I want you to visualize Hooke's law in the following manner. As we have stated earlier, that Hooke's law was stated by Robert Hooke in 1660. As you write Robert Hooke in 1660, you can see that there are too many O's present in this short phrase. Now, if you visualize this law as a law which contains too many O's, you can certainly remember that which scientist stated this law and in which year it was stated. The double O in Hooke and the double O of 6 in 1660 helps you to remember that it is a law containing too many O's. Now, how can we memorize that what is Hooke's law about? Now, visualize Hooke's law as any material that is suspended by a hook, and the greater the stretch, the greater the force. I hope in this way you will remember the scientist, the year in which it was stated, and the concept of what's Hooke's law about. Just remember the O's. Do subscribe to stay updated. See you in the next video.